So if I go 2 standard deviations in mean, that and my mean is, or my standard deviation is 4, then I'm going to go then plus 2 times 4 and then find that out. And so then in other words, 4 times 2 is 8, plus 70 would be then 78. So 78 would be then 2 standard deviations above the mean. How many inches is, give me 70 inches since we did the conversion before. What is 70 inches in feet and height, in feet and inches? How many is 60? How many, if I go, you're 60 inches tall, you would have to, how many feet would that be? From our conversion before. You got it? Levi, did you get your calculator? Okay, so Asher, take 12 times, or 60 divided by 12. 5. So 5 feet is 60 inches. That means that the next 6 feet would be then how many inches?
5, 8, 12.
We'll go 6. If I go 6 feet, it would have to be 6 times 12. So 6 times 12 is what? It would also be 60 plus 12. Are we going to get it?
72.
72. So 72 inches, okay, is going to be then 6 feet flat. So how many, if I know 72 inches is going to be 6 feet, then what is 78? 6 foot, how many inches? 6. How many 6'6" people do you know? Asher, how tall are you right now?
6'1".
6'1". So how many what is Colin Hagman? Any idea? He's pretty tall. He's tall. I know John Borchard's. You guys know who John Borchard is? The PA that's real tall. John is 6'4". So again, so when we talk about then someone who's 78 inches, which would be then 6 feet, and then which is above 6'6", then it's 2 standard deviations above the mean. That means there's only, in this case, if I look about from 2 standard deviations above the mean, that means it's the 95th percentile. So that means there's not many people that are 6'6" or above. All right, tell me how to find, Asher, tell me how to find the height that is 3 standard deviations below the mean. What would you do?
I do 70 plus 3 times 4.
You got an idea. Since it's below, so do 70 minus then 3 times 4, and you got it. So then, in other words, I'm going to go 70 minus 12, and 70 minus 12 would be 58. Just checking my work. Is that correct? Okay. So 58 inches is going to be then 3 standard deviations below the mean. And if I go 3 standard deviations below the mean, 58 inches would be then, remember, 60 is 5 foot, correct? So that means it's actually like 5'10". So not many men, you know, probably that are, oh, wow, that's even less. Sorry, I got that wrong. So 60 would be, that would be 4'10", wouldn't it? So 4'10", something like that. That would be pretty small. All right, so then, Brian, tell me how to find the height that is 1.5 standard deviations above the mean. Yep. Okay, so 70 times 1.5 times 4, 1.5 times 4 then is going to be 6, and so it would be then 76. Okay, Levi, find the height that is 1/2 a standard deviation below the mean. What are you going to do? Okay, and 1 times 4 would be 2, so that would be then 68, correct?
All right, so when I break down the standard deviation and do a little bit more with that, we know that 50% of the values are going to fall right at the mean. And notice you have this little symbol here. This symbol here, whatever, I'm going to just go ahead and put an arrow here, means the mean. And what it is, it's also the mean of a very large data piece, a large amount of data. Okay, so you have to have, if you have a small sample set, then you'll use your mean as the bar that we had before, which is the X bar, or even just the mean. And then notice then we have this little symbol here, which is going to be like the S. So this symbol right, that is also indicating standard deviation of a large sample set. Okay, we had S before representing the small sample set, but when you have a large sample set, then it changes then to the sigma, which is the Greek letter. So in this case, we know that 50% is going to be the mean, and then each standard deviation, like this represents the mean plus 1 standard deviation, and then we'd have the mean plus 2 standard deviations, etc. And then the same thing going to the left, then you would have the mean minus 1 standard deviation. So in this one, it says the male heights of North America are approximately normally distributed, with the mean again being 70 inches and a standard deviation of 4. So it's a pretty standard deviation, just normal distribution. It says find the percentage now of the men in North America with heights between 66 inches and 74 inches. Now, what they've done here, if you remember, this is going to be then 70 minus the 4, which is the same as the mean minus 1 standard deviation. And again, the 74 would be found as 70 plus 4, which is going to be 70 plus 1 standard deviation. And notice then if I go from 66 to 74 inches, what we're looking at is all of the shaded area. And they're also going to give you that amount, and that box would be then the 68%. So the percentage of the men that would fall between 66 inches and 74 inches would be 68%. The next one says find the men in North America with heights of 62 inches and 78 inches. So Asher, can you tell me what that would represent? What percentage?
95.
Yep. And again, he's looking from here to here, and that would be then the 95%. Find the percentage of men with heights between 58 inches and 74 inches. Okay, so in this case we have to think about it a little bit. We're not going to be able to go to the 99.7 because the 74 inches doesn't include that. Okay, so what you can do is, we can subtract off that last amount. You know that each of these is going to be like divided, like the 68 would be then 34% and 34% would indicate the 68%. And then to find out even just this little blue section here, then again I can go ahead and say, well, I know that all of it is going to be 95, but I could subtract then the 68, and that would divide it by 2, and that would tell me what each little blue section would be. So 95 minus 68 divided by 2 would be then 13.5. And this side would be then 13.5. Okay, and I can continue doing that with this next section because I need to know on 58, I need to know what this section would be. So again, if I go 97.7, I know that I could subtract then the 99.7. I'm going to subtract out the 95. And then I know that on each section then I'm going to have that 4.7, so I would divide it by 2, and I know that this little tiny section would be then the 2.35. And then I could just go ahead and subtract that out. So again, from the 58 to 74 then would be then the 2.35 plus the 13.5 plus then I would have the 34 plus 34, which would be then the 68, plus then another 13.5. And again, what I would probably do is also just multiply this one by 2. So I would have I could go 95% plus 2.53. And that would give me the 97.35%. The next one, it says find the percentage of North America with heights greater than 78 inches. Any idea on what would you guys do to solve that one? Greater than 78. So I know that if it's below 78, then I'm going to and actually if it's two standard deviations, I'm in the 95% rate, correct? So that would indicate this would have to be then the 2.5 going above. So I could go ahead and again subtract the 95, so I go 100% minus the 95, and then I would divide that by 2 because I only want half of it, and so that would be then the 2.5. Do I lose ya? Okay, what I did is I found each of the areas here. So I said, well, if this 68 has to be 34. Did I? Oh, so I should have stopped at. I should not have had the extra 13.5. You're correct. So let's take that one out. So it should be 34, 34. Well, actually, I could end just doing this. This is going to be half from everything from 70 below. Let me just change that because I went too far. You're correct. I went to 78. So in this case, it would just be then 50 plus 34 would actually get me that same amount. Because 50 would give me to 70, plus 34 then would give me then to the next 74. And so that would give me 84%. But then that would give me, I need to take off the little amount from 58%. I'm not doing that quite right. Okay, hold on. So if I do, if I do from 58, okay, so does that make sense on how I got the 34?
Yeah. Okay.
The next one, to get the 13.5, what I did was I subtracted 95%. Let me go 95. That one actually is going to be, so 68 is 34, so 95 divided by 2. So here, 95 divided by 2 would give me how much is going to be from here to here, but then I want to subtract off the 34. So this is how, that's the 13.5.
Yeah.
That's okay?
So you just add 2.35.
Yes.
13.5 plus 34 plus 34.
Yes, I just went an extra 13.5 because I went to 78 rather than 74.
I got it.
Okay? So let's change that. That should be then 2.35 plus 13.5 plus, and I'll just go ahead and do 34 and 34, which would be then the 68. So now change that 83.5. Yay! Okay. Now if we go to the last one, greater than 78 inches, then again I'm gonna go ahead and say, well, if I go from 78 inches, I know from going half is going to be then 50%. Okay, so all of this below that is 50% plus 34 plus the 13.5 gives me how much will be up till lower than 78. So let me just do that. I'm going to go 100 minus, then I will have 50 plus 34 plus 13.5, and then that will tell me what's on the other side. So 50 plus 34 plus 13.5 is 97.5, and then I'm going to subtract it from 100. And that's where I'm going to get the 2.5%. Are we good there? Is it clear as mud? Does that kind of make sense on how I got that part? Levi, are you good?
No, I just thought of 2.35. Go past the 82 a little bit.
Yeah, it does go, that you're forgetting that little tiny bit. Okay. So, the other kinds of distributions, this graph represents the population of weekly earnings in the United States, and there's no upper limit on the weekly earnings, and the relatively few people have a very high weekly rate of income, and pull the mean. The weekly income pull means that the income of the greater value than the median, and it's the most frequent income. The mode occurs towards the low end of the data items, and it's called the skewed distribution because of the large number of data items that were piled, with the other tail at the other end. And so this is a graph that is skewed to the right, and that always bothers me a little bit, okay? Because when I see that the height is actually on the left-hand side, to me, I think it should be, they should have told it to be skewed to the left. So in this one, they're actually talking about the skew is more to the tail. So when the tail is over to the right, then that's going to be skewed to the right, okay? And meaning that the high point is going to be the left. If I have a graph that looks a little bit just the opposite, then this one is going to be skewed to the left. And again, it's not really talking about the height where you're talking about the mean of your data points. It's actually talking about where the tail is going and where the tail is larger. And that's the indication of whether it's going to be left or right. Okay? All right, so that ends our lesson for the whole unit this year, or for this, not for the year, but for chapter 4. So tomorrow I will have a review ready for you, and then we were looking at having maybe the unit test on Thursday. Does that any conflicts with that? Okay, we will do that on Thursday. We'll have 2 days to review. I will also have the Excel file, because remember, I'd like you to be able to take an Excel piece of data and also make a frequency distribution, and then also find it and calculate the mean, median, and the mode by just the Excel file, or the Google Sheets, I should say.
Friday or Thursday?
Thursday is when I was going to do the test. Would that work?
Have one day to study?
Well, you'll have, yeah, we'll do the review all day tomorrow. Would that work?
Yeah.
Okay. Okay. And then I'd like to do the start of the first one by Friday. Now you guys will have the game Friday night, correct? Here or away? Okay.
Here.
Yep.